Have you ever looked up at the night sky and thought, this doesn't make sense? There are hundreds of billions of stars in our galaxy alone. Many of them have planets. A good number of those planets are in the right place for liquid water. Life appeared on Earth almost as soon as conditions allowed it. Intelligence followed. Technology followed. Radio signals followed. So, where is everybody? This is the Fermi Paradox. And after 70 years, it still doesn't have a satisfying answer. The paradox is named after the physicist Enrico Fermi. In 1950, during a casual lunch conversation, he simply asked, "Where is everybody?" The math is brutal. Even if advanced civilizations are rare, say, only 1 in a million stars ever produces one, there should still be hundreds of thousands of them in the Milky Way. Some of those civilizations should be millions or even billions of years older than us. They would have had plenty of time to colonize the entire galaxy, or at least leave obvious traces. Radio signals, megastructures, probes, something. Yet the universe is silent, not quiet. Silent. That silence is the paradox. There are dozens of proposed solutions. Most of them fall into a few big categories. First, we're early. Maybe intelligent life is extremely rare, and we just happen to be among the first. The universe is 13.8 billion years old, but the conditions for complex life may only have become common relatively recently. It's possible we're looking at a mostly empty galaxy because the real party hasn't started yet. Second, the Great Filter. This is the darker idea. Somewhere between simple life and galaxy-spanning civilization, there is a nearly impossible step, a filter that almost no species survives. It could be behind us, the origin of life, or the jump to complex cells, or the rise of intelligence. Or it could still be ahead of us. Nuclear war, climate collapse, artificial intelligence, something we haven't even imagined yet. If the filter is still ahead, the silence is a warning. Third, the zoo hypothesis. Advanced civilizations know we're here, and they're deliberately not contacting us. We're a protected nature reserve, or a reality show, or an experiment. The moment we become interesting enough, or dangerous enough, the quarantine lifts. Until then, the universe pretends to be empty. Fourth, they're already here and we just don't recognize them. Maybe their technology is so advanced it looks like natural phenomena, or they're post-biological and no longer interested in planets, or they communicate in ways we haven't thought to look for. Some explanations get stranger. One possibility is that technological civilizations inevitably destroy themselves within a few hundred years of inventing radio. The window between we can send signals and we wipe ourselves out is short. If that's true, the silence isn't mysterious, it's statistical. Another is that we're living in a simulation, and the simulators simply didn't bother to fill the rest of the universe with aliens. That one is hard to test, but it does solve the paradox cleanly. There's also the idea that interstellar travel is simply much harder than we think. Not just expensive, fundamentally impractical. If you can't cross the gaps between stars at any meaningful scale, then every civilization is stuck in its own solar system, shouting into the void with no one able to answer. Despite the silence, we keep looking. SETI projects listen for radio and laser signals. New telescopes are scanning for industrial pollution in exoplanet atmospheres. Researchers study technosignatures, anything that would be hard to explain with natural processes. So far, nothing definitive. A few interesting candidates have appeared and then faded. The universe continues to look empty of intelligent neighbors. That doesn't mean they aren't there. It only means that if they are, they're either extremely rare, extremely quiet, or extremely careful. The Fermi Paradox isn't just an astronomy puzzle, it's a mirror. It forces us to ask what kind of future we're building. Are we going to be one of the civilizations that makes it past the filters? Or are we going to become another quiet data point in someone else's paradox? We don't know the answer yet. Maybe we never will. But the fact that we can even ask the question, that a species on a small planet around an ordinary star can look up and wonder why the sky is so silent, is already remarkable. So the next time you look at the stars, remember Fermi's question, where is everybody? And then ask the quieter, more important one, what are we going to do about it?